All right, y'all, so we're recording, so let me go to my camera. All right, so what I did, I just printed out a test tree review to use for my lecture today. Let me let some more in real quick. All right, so question one, they want me to use the end behavior diagram to describe the end behavior of this function. So the two things we made a chart, we looked at the degree, whether the degree was even or odd, and then we looked at that lead coefficient. So on our chart, our degree is 6, so the degree is even. And then that is a negative pi, so my lead coefficient is negative. So when my degree was even and my lead coefficient was negative, it looked like the upside down parabola in the big picture. So we go with A. Now you can graph these and zoom them way out and you'll eventually see that both ends are going down on that, okay? So y'all, I would use my chart for that one. Same thing on number 2, I would use my chart for this one. So the end behavior, so we're looking at the degree again. So the degree is the highest exponent. So this time my degree is odd. So watch for these being out of order, okay? All right, so I got an odd degree. That 0.4 is positive. So when we had an odd degree that was positive, it went uphill left to right, which would be A. Okay, so them two definitely I would use my chart on. Number 3, they want me to find the zeros and state the multiplicity. Well, the multiplicity is always these numbers on the outside of those parentheses. So that means we will have multiplicity 4. Now to solve this, you had to take that x squared minus 16 and set that factor equal to 0. So if you want to quad this on quad, A is 1, B is 0, C would be negative 16. So since there's not an x in the middle, B would be 0 on quadratic formula. So I'm going to show y'all how to solve this. I would just add 16 and take square roots. So that you get x squared equals 16. So anytime you just got an x squared term and a number, easiest thing is square roots. So now you come in and take those square roots. So that square root of x squared is x, and that's going to equal a plus or minus 4. So remember, square roots can be negative times a negative, or it can be a positive times a positive. So that's why you got to use both signs. So over here they got plus or minus 4, plus or minus 4. So it's either going to be A or B for us. So then we got to look at our multiplicity. And our multiplicity was that exponent of 4. So I need a plus or minus 4 with a multiplicity of 4, which would be B for us, okay? So that's the trick on those. You're just taking what's inside those parentheses and setting them equal to 0. Same thing on my number 4. Find the zeros of the polynomial and state the multiplicity. Well, the multiplicities are all these exponents on the outside. Now notice, this negative 2 does not have a variable. So since that factor does not have a variable, we're going to cancel it out because there's no way it could have a 0. Now what you will do is take the 3 other factors and set them equal to 0. So 2 of these we got to solve. So the first one I'm going to add 2, and I get x is 2. Second one, I'll subtract 5 and get x is a negative 5. My third zero was 0. All right, so notice they said the 0, 2 has a multiplicity. Well, I got the 0, 2 from the factor x minus 2. So since it's got a 4 exponent out there, it would have an exponent of 4. Then it says blank is a 0 of multiplicity 2. Well, the factor that gave me a multiplicity of 2 was the x plus 5. And when I solved that, my 0 was negative 5. And then it says, hey, the remaining 0 is 0. And that one had a multiplicity of 3. So when it's a single variable, the multiplicity is equal to the exponent. When it's in factored form, the multiplicity equals those exponents outside those parentheses. All right, y'all, so that's my first 4. So let me get this moved back up. So this one says find the zeros and their multiplicities. So I'm actually going to write this one down. So this one was f of x equals x to the third minus 4x squared minus a x plus a 4. So in order to find the zeros of this one, since this is a 4-term polynomial, this is the ones where I did the factor by grouping. And on each of these pairs of factors, I'm going to factor out the GCF. So the first pair, I got an x cubed and a 4x squared. The GCF would be an x squared. Inside the parentheses, you would have an x minus 4. So subtract exponents. 3 minus 2 left me to 1x. And then 2 minus 2 left you 0x's, so that 4 had to come down by itself. Second GCF always has the same sign as that third term. So since that's negative, second GCF will be negative. All right, y'all had to shut that door real quick. All right, the only common factor between an x and a 4 is a 1. So you at least got to factor out a 1 on that second GCF. So factoring out a negative 1 will change both of these signs. Negative divided by negative makes that a positive x. Positive 4 divided by negative makes that a negative 4. So remember, we're good because our parentheses are matching up now. So that's the main thing you need, is for those parentheses to match up. Since the parentheses match up, you're now going to factor out that x minus 4 like a GCF. In the second parentheses, you put everything else. So once you pull them x minus 4s out, all that's left is the x squared minus 1. Now that I've got it factored, I'm going to set it equal to 0 so that I can find all my zeros. Now notice, there's no exponents on the outside of these parentheses, so we would treat both of those like they got a 1 on the outside, which means whatever factors I get out now are going to have multiplicities of 1. All right, so we set our factors equal to 0. So the first one's pretty quick. We just add 4. Second one, I would probably add 1 and do the square roots again. Or you could do the quad. A would be 1, B would be 0, C would be negative 1. All right, y'all, to finish this, I'm going to take square roots. So the square root of x squared is x. Square root of 1 can be a plus or minus 1. So we got 3 zeros, 4, -1, +1. Each of them has a multiplicity of 1. So let's go back here. So up here, the zeros would be what I say I got a 4, 1, and -1. And then each zero had a multiplicity of 1. Okay, so factor by grouping is not too bad. You just got to make sure those parentheses match up while you're working through it. All right, y'all, true or false? If P of x equals x minus 2 to the 4th times x plus 1 to the 7th, then the graph of this polynomial function, y equals P of x, crosses the x-axis at 2, 0. So they're looking at 2, 0, and they want to know if we're going to cross at that point or not. So remember, for it to cross at that 0, the exponent has to be odd. If that factor has an even exponent, then it's tangent. So let's find out which factor gave us a 0 or 2, and that would be the x minus 2 factor. But y'all, it has a exponent of 4 by it. That's an even number. So since it's even, this would be tangent at that 2, 0. And they're saying it is going to be crossing. So that is definitely false. And then you just look at the answer. Since 4 is even, it's going to be tangent like we said. So we would go with A on that one. And then the other false one is trying to say that the 4 is odd, okay? So watch that. They just mix up the even and odd on that to mess you up. All right, so that's all you do. Look at your 0, which factor it came from, and is that exponent even or odd? Even it's tangent, odd it crosses. All right, 7's not that bad. They want to know what's the maximum zeros, maximum x-intercepts, maximum turning points. Or the maximum number of real zeros is equal to the degree of that polynomial. So since that polynomial is a degree 4, it has a maximum of 4 real zeros. Well, x-intercepts and zeros are the same thing. So if it's got a maximum of 4 real zeros, it's got a maximum of 4 x-intercepts. So y'all, the one that's going to be different is the maximum turning points. In the maximum turning points, you took the degree and you subtracted 1. So my degree is 4, subtract 1, that's going to leave me a 3. So I don't care what kind of polynomial they give y'all, you're going to have answers like 443, 554, 221. But the zeros and x-intercepts got to match, and then them turning points got to be 1 less, okay? All right, y'all, so this number 8 is similar to knowing those charts. I'm going to look at the degree and see if that leading term is positive or negative. Now, to find the degree on this one, since it's all factored out, to find the degree, you would multiply all these x's together. So the degree will equal x times x times x times x, which is x to the 4th. All the x's got a 1 in front of them, so this is a positive 1x to the 4th. So my degree is going to be even. My lead coefficient is going to be positive. So y'all, that's all you got to watch out for is that sometimes they make that first x negative, and that's going to change your lead coefficient, okay? So factored form, just multiply all the x's together. So x4 even and positive in the big picture, both ends have to go up. So notice this first one. It's going down and up, but it's going uphill left to right in the big picture. Same thing here, left to right, uphill. This one is upside down. If it was negative in an even exponent, it would look like that one. But ours was even and positive, so it should be going uphill both sides, which is what D has right here. Now, I'm going to show you how you can get this exactly on your calculator. Notice the Y values on their graphs go from negative 100 to a positive 100. So I'm going to go on my calculator, punch this in, and show you what it would look like. So let me share that screen real quick. So I'm going to go to my Y equals. And I'm just going to punch it in like it looks. They have an X, and then parentheses, X minus 2. Next parentheses was an X plus 3. And then my last parentheses was an X minus 6. So y'all, we got these powerful calculators and they can do all this graphing. Now to set them Y minimum and maximums equal to their graph, I'm going to hit window and I'm going to arrow down until I get Y minimum. So Y minimum for them was negative 100. And then I'm going to arrow down to the Y max, which was a positive 100. When you put your window to match those graphs, when you hit graphs, watch this, you'll see exactly what they had on that picture. So there it come down, remember it went up, came back down, and then went back up. Okay, so look at that graph and then look at our picture. And you see that it was, in fact, number D there, okay? All right, so that's first 8. Number 9 is the same thing, and I'll show you, we'll set our windows to what they got on theirs. But what I'm looking at on this is that is an odd degree, and that 8 is positive. So when your degree was odd, and you had a positive lead coefficient, left to right, this thing should be going uphill. But notice, you got 2 graphs that are going uphill left to right. So when the 2 graphs match, you got to look at the y-intercept. The y-intercept is that last number. So our y-intercept would be 54. So one of these looks like it's crossing at 54. So look at A. A looks like it's probably at about 50 something because that's going up to 250. C is crossing right at 0. So the correct answer would be A, since the y-intercept is up here about 54, okay? And then, like I said, let me graph that in real quick, and we'll see one of them pictures exactly. So I'm going to go y equals and clear that out. So this was 8x to the third. So 8x to the third minus 6x squared minus 72x plus 54. So watch this. I'm going to go to the window. Their x's went from -5 to 5. So I'm going to change that to a -5. Arrow down. Make that a +5. Then their y values went from -250 to a +250. Since I set my window, when I graph this, I will get one of them 4 pictures. And y'all look at this. This one's going up. And you can tell it's crossing at about 1/5 of that axis, okay? So you can tell there's definitely a gap, which means you would have to go with that picture A that I was showing you. Okay, so that had a little gap there, and then like I said, C went right through the middle. So be careful on that one. All right, next I want to know, using synthetic division, determine whether these numbers are zeros. If they're going to be zeros, then that remainder has to be 0, okay? So let's do the first one. We got to write out our coefficients. So 1, 4, 3, -4, -4. And I'm going to draw my box. So the first number I'm checking is this -3, so it becomes my C. So we're looking for a 0 remainder to get a yes. Any other remainder is going to be a no. So remember, first number, bring that 1 straight down. Then you're going to multiply. 1 times -3 is -3. 4 minus 3 is 1. Then you multiply again. 1 times -3 is -3. Add that together, you'll get 0. 0 times -3 is 0. -4 plus 0 is -4. And y'all look at that. That -4 times -3 gives me a 12. And 12 minus 4 is 8. That is not a 0, so that means -3 is not a 0. Now we're going to check 1. So we bring down our numbers again. 1, 4, 3, -4, -4. And this time we're checking the 1. All right, so let's see what happens. We bring the 1 down. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 3 plus 5, 8. 8 times 1 is 8. 8 minus 4 gives you 4. And then 4 times 1 is 4. So I get a 0 remainder. So that means yes, 1 is a 0 of that polynomial. All right, now we're getting into the stuff where we had to do a lot of FOILing. So let me write down my numbers for that number 11 there. So number 11, I'm going to find a polynomial degree 4. It has a -4 as a 0, multiplicity 3. So that means that 0 happens 3 times. And then it's telling me 0 is a 0, multiplicity 1 time. All right, so degree 4 polynomial, -4 is a 0, multiplicity 3. 0 is a 0, multiplicity 1. So I always put my zeros first. So that means x equals 0. And then I'm going to have x equals -4 3 times. So degree 4 has to have 4 zeros sitting right here, which we do. So now we had to get a 0 on the right side. So that one's good. So the other ones, I'm going to add 4 to both sides. So I now have 4 equations set equal to 0. So the product of all these will still equal 0. So I came down and brought that first x and then my x plus 4 3 times. All those can now be set equal to 0. And remember, since this was a 0, that means it was treated like a greatest common factor, because greatest common factors are always the ones that gave us 0 for those answers. All right, here's what I'm going to do. I'm going to distribute the x through the first parentheses, and I'm going to FOIL the second parentheses. So if we distribute this x times x is x squared. x times 4 is 4x. So I distributed my x in the first parentheses. The second one, we're going to FOIL this. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. Now I'm going to do one more step. I'm going to bring down my first parentheses. Cannot do nothing else there. But y'all, my second parentheses, I'm going to add the like terms to make that a little shorter. So I'll bring down that x squared. 4x's and 4x's will give me 8x's in here. And then my 16. So we just sort of distributed and FOILed. Now we got two sets of parentheses. We're going to FOIL that out now. Sooner or later, we need to get a degree 4. And y'all watch this. X squared times x squared is an x to the 4 like we needed. X squared times 8x is an 8x to the 3rd. So I'm basically adding x squareds to everybody through here. And then x squared times 16 is a 16x squared. So all these went up by 2. Now we distribute the 4x. So 4x times x squared is a 4x to the 3rd. 4x times 8x is a 32x squared. 4x times 16 is a 64x. All that equal to 0 technically. So I got one more step, and that's to combine all these like terms. So let's see, we bring down that x to the 4. Your x to the 3rds will add together. So 8 and 4 give you 12 of the x to the 3rds. These x squareds will add together. So 16 and 32 give you 48 x squareds. And then at the very end is my plus 64x. So let's see, MATLAB, all we got to do is put in the actual polynomial. So let me go write that in here. So that'd give me what, an x4 plus 12x to the 3rd plus 48x squared plus 64x. So when you're putting in your answer, you don't have to put the equal 0. Okay, we just do that so we're working backwards. All right, 12. They're saying, hey, you got a degree 4 polynomial, and it has the following zeros. Find the other zeros. So that means there's a total of 4 maximum zeros. They gave me 2 of them. So on this question, they want you to realize that if they give you I as a 0, then its conjugate, which is a negative I, is also a 0. If they give you a radical as a 0, 4 minus square root of 5, then its conjugate, 4 plus square root of 5, is also a 0. So that one, you just had to realize that the i's and the radicals always come in conjugate pairs on them zeros. All right, I'm probably going to write this number 14 down, so let's see. So they're giving us f of x equals x to the 3rd plus 5x squared minus 2x minus 10. And they're saying, hey, negative 5 is a 0. Whoops. All right, let me get that back. So negative 5 is a 0. So that means if negative 5 is a 0, I can use that in synthetic division, because my goal in synthetic division is to get it down to 3 numbers that I can use on my quad, okay? So let's write our numbers down. We got Degree 3 has to have 4 numbers. We got them. I got a 1, 5, -2, -10. And they're giving me a 0 of -5. Y'all, since they're giving me that 0 as -5, your remainder gotta be 0 after this synthetic division, okay? But what that's going to do, that's going to give me 3 numbers here, and I'm going to use my quad. So 1 times -5 is -5. 5 plus -5 is 0. 0 times -5 is 0. -2 plus 0 is -2. And then finally, -2 times -5 is 10, which gives me a 0 remainder. So they gave you that 0. We're going to find the other 2 zeros now. 2 ways you can use this. You can use quad. A equals 1, B equals 0, C equals -2. And this one actually you can solve by square roots, because the 1 is the x squared term, plus 0x's minus 2 has to equal 0. So you can set it up and just solve this real quick by adding 2 to both sides and then doing the square root. So that's going to be a plus or minus since I'm taking the square roots. And y'all, we cannot break down the square root any further, so that's going to stay a square root of 2. So the first 0 they gave me -5. The other zeros were square root of 2 and a negative square root of 2. So let me see how they wanted us to write that. Oh, you just got to put the plus or minus square root of 2 on that, okay? All right, so let me show you. Yeah, all we'll do is just come in here, plus or minus square root of 2. Don't put the -5 in there, the one they gave you, because what happens if you put -5 also, it will mark those wrong, okay? So since they gave you that one, you don't have to put that in with your answers. All right, let me get my papers situated. All right, 15 is a fun one. They want me to list all possible rational zeros. That's where I did the P divided by Q. P is the last number 7. Q is the first number P. So what we got to do is find all possible combinations of all the factors of P divided by all the factors of Q. So P is going to be 7, and the only factors of 7 are 1 and 7. Q is equal to the 15, and hang on a second. Get up. All right, had to let the dog out real quick. So the factors of 15 would be 1, 3, 5, and 15. So we need to find all the combinations of 1 divided by all these numbers and 7 divided by all these numbers. So our plus and minus P over Q's would be plus or minus 1 divided by 1, plus or minus 1 divided by 3, plus or minus 1 divided by 5, and then plus or minus 1 divided by 15. So now you would reduce any of these. So 1 divided by 1 would just turn into a plus or minus 1. So that's all the factors of the 1 divided by them. Now we're going to find all the factors of the 7 divided by these 4 numbers. So I got 7 over 1, 7 divided by 3, 7 divided by 5, and then 7 divided by 15. And then once again, I can turn that 7 over 1 into just a 7. So let's look over here. Well, I didn't have no 3's in 15, so it's not a. So here I go. I got a plus or minus 1, plus or minus 7. I got a 1/3, 1/5, 1/15, 7/3, 7/5, 7/15. So for me, I'm going to go with B. C, they didn't list the 1 and 7, and on D, they did upside down and divided everybody by only the 7. So all factors of the last number divided by all factors of the first number. All right, y'all, 16 was a domain. Find the domain. So the domain, I'm only worried about setting the bottom equal to 0. So you're going to set x squared plus 7x plus 6 equal to 0. You can use the quad if you want to. 1, 7, and 6, and it'll spit out your answers fast. I'm going to factor this. I got an x and an x. Last sign's positive, so both of these will be positive like the middle number. And then factors a 6, that'll equal 7 or 6 and 1. So then take each of these factors and set equal to 0. Solve them by subtracting. So I get a -6 and a -1. So I got two numbers I'm excluding. So I got to go down here and use C for my answer. Because C says x is the real number and x. Now here's where they're going to catch you. They want you to use ascending order. That goes from the smallest number to the biggest number. So between a -6 and -1, the first one you got to list is -6, and then your -1. So ascending gets bigger, descending would get smaller. So y'all just remember a -1 is definitely greater than a -6. And the reason they're doing that is because when you use your interval notation, your numbers will be in the same order as this is, okay? So for interval notation, we start at -infinity until we hit -6. Union around that -6 until we hit -1. Union around that -1 till we hit positive infinity. So whatever numbers you're excluding from your domain, you got a union around those numbers. And then remember, the domain is going to start at -infinity on one end and have a positive infinity on the other.
Can you start at the beginning of that? You went through very quickly.
Okay, so since I was looking at the domain on this one, the only way that that can have a 0 in that denominator is if there were values of x that would make that equal 0. So what we did, we set that denominator equal to 0 and solved it. So I solved mine by factoring, but y'all could have used a quad and put in a 1, 7, and a 6 on that. If you use quad, it would actually give you these two answers. So I sort of factored it, and I knew I could find factors of 6 that would give me 7, and that was 6 and 1. So remember, once you got it factored, you actually got to solve for each of them variables so that we can get values over x's to exclude. So that's what I was doing over here when I had my +6 and +1. I subtracted 6 from the first one on each side to get that x by itself. And then that second one, I subtracted 1 from both sides to get that x by itself. So we had to pick the answer choice C because it had two blanks and we had two numbers. So what I was wanting y'all to watch out for on that, this one wants it in ascending order. So ascending order goes from your small number towards your bigger number. So that's why that -6 had to be before that -1. And then here we're just putting them in interval notation. So each of these numbers, you got a union around to kick them out of your domains. So look, number 17 is the same thing, right? Find the domain of this. So once again, all I'm worried about are any numbers that can be put in for them x's to make the bottom of the fraction equal 0. Notice, on neither one of these problems, since it's a domain, I don't care what the top does. Only thing that can't be 0 is that bottom. So we're going to set x squared plus 2x minus 35. We're going to set that equal to 0 and solve it again. So at this point, quad would be 1, 2, negative 35. So you got an x squared, which would be an x and an x. This time, that last sign is negative, so that means these will have unlike signs. And factors of 35, that'll give you a positive 2, would be a positive 7 and a negative 5. All right, then we're going to finish this off by setting my little factors equal to 0. So y'all, the first one, I'm just going to subtract 7 from both sides so that I get x is a negative 7. And then since this was x minus 5, we'll add 5 and get x is a positive 5. So the two numbers we're going to kick out of our domain are negative 7 and 5. So it's going to start at negative infinity. The first number it hits going left to right would be negative 7. So union around that negative 7. From negative 7, you're going until you hit the 5. Union around that 5. And y'all, since that was the last number I'm kicking out, I'm heading off towards positive infinity. So this one only had to have interval notation to where that first one, number 16, made you pick the one for set builder notation, and then you had to come back and write it in interval, okay? All right, so let's see. On the asymptotes for horizontal, I gave you 3 cases yesterday. They could be the equal degrees on top and bottom. The top could be heavier, or the bottom could be heavier. So on this problem, you got a degree 2 on top, degree 4 on the bottom. So the bottom is greater than the top degree. Anytime the bottom is greater than the top, the horizontal asymptote will be A, and it is y equals 0. So the only 3 choices you had on that was 0. It could be A over B, which would be the numbers in front, or there would be no asymptote. If the top was bigger than the bottom, then you would have no asymptote on that, okay? All right, let's see what they got me doing here. I need to scoot back up. Solve the following inequality. So on this one, this is where I made a number line and I had to pick a test point. So I'm going to write that on another piece of paper real quick. So I got number 19 is x minus 3 times x plus 1 is less than 0. So let's solve that, and then we'll put this answer in interval notation. So it's already factored. So what you need to do is come in and solve each one of these factors by setting them equal to 0. And you know, I think that's the only number we ever set anything equal to in this class is 0 pretty much. So let's see, add 3 to the first one, and then subtract 1 from the second one. And I'm hoping that y'all are seeing that factors and solutions, factors and zeros always have opposite signs on them, okay? All right, so I would make me a number line. -1 would be here, 3 would be here. So you got to pick a test point. So I always pick 0, because 0 is the easiest number I can plug into stuff and get solutions out of. So we're going to test 0, which is in between -1 and 3. So plug a 0 into this equation and see if it's less than 0, true or false. So 0 minus 3 times 0 plus 1 has to be less than 0. So -3 times 1 has to be less than 0. So y'all, the question, is that true or false? That is definitely true. So since -3 is less than 0, true, I shade the area where the 0 was located, which is right in the center here. Now, interval notation. Do I want to use parentheses or brackets? And all I'm looking at to determine that is that little inequality.
Brackets.
Since there is no
Parentheses.
equals under that, oh, I think I heard it. Y'all said parentheses?
Yes.
Yep. So that one actually have parentheses since we don't have that equals under it. So y'all come down and make that interval. -1 on the left side, +3 on the right side. Since that's the only section shaded, that's the only interval we have for our answer. So then when you write that in here on your answer, you actually got to put it in interval notation. What I get, -1 to 3. Make sure you put them parentheses there or it marks that wrong if you just put numbers, okay? All right, same thing on number 20, except on 20, I didn't give you the factored form of this. So this one, we got to factor by ourselves. So we got x² plus 19 is less than 8x. So to solve this, we need a 0 on the right side. So we would have to subtract 8x from both sides. So basically all we're doing, we're moving to 8x, that was positive on the right side. We're moving it to the left side and making it negative. Now I'm going to put them in order. X² minus 8x plus 19 is now going to be less than 0. So at that point, if you're weak at factoring, you can try to factor that. So we're looking for answers that are real numbers, okay? We can't have imaginary type answers and all that stuff. So to solve this, I would try to factor that. So x² would be an x and an x. Since that 19 is positive, both of these would be negative. So can y'all find me factors of 19 that would add to get an 8? So that's probably not happening, is it? No factors of 19 are going to equal 8 because the only factors of 19 are 19 and 1. So this one does not factor, which means it is a no solution. Now, I forgot to show y'all this yesterday, but on MATLAB, when you got a no solution, when you click in that answer box, it pulls up all them extra keys on the bottom. You'll see one that looks like a 0 with a slanted line through it. You can use that for no solutions on that, and it'll let you put that in there and be done, okay? So y'all, that is what you want to play with today is your test 3 review and then your test 3. Now, if you wait till Sunday to do test 3, that means that next day you're going to be doing test 4 because we will be done with test 4 material by this Friday. It's a very short few sections we got to do, okay? I think there's like 4 sections. So we'll have all that done by Friday, which means next Monday I'm reviewing for test 4. Test 4 will be due by Thursday, August 5th. I'll review the final exam Tuesday and Wednesday as much as we need to. Final exam will also be due Thursday, August 5th by midnight. So whatever y'all don't get done this week, remember, it's definitely going to be due by August the 5th.
So we've got test 4 and the final exam due next week.
Yes.
Okay.
Oh, hey, I did miss one. So let me knock out this number 13. Someone just let me know I did miss the 13. So let me do this real quick. Same as usual. All right, y'all. So let me go back and get my paper. So 13 was, yeah, y'all need to see this one probably. So 13, and I see I wrote all around it. So 13 wants me to find a polynomial of lowest degree, and they're giving me two of the zeros, square root of 3, and a 5i. So let me bring down here a square root of 3 and a 5i. And this is number 13. Oh, I'm glad y'all caught that because that's a tricky one.
Can you scoot it down just a tiny? Oh.
Is it better now? All right, which means if square root of 3 is a 0, that means a negative square root of 3 is a 0. If 5i is a 0, then that means a negative 5i is a 0. And the reason they're telling you that it's the lowest degree, because they don't want to give it away that there's actually 4 zeros on this, okay? If they'd have told you it was a degree 4, then you'd automatically knew, oh, there's got to be some missing ones. Just remember, anytime I give you a radical or imaginary, their conjugates are going to be zeros also. Now I'm going to put them together. I'm going to put x equals square root of 3, x equals negative square root of 3, x equals 5i, x equals negative 5i. I'm going to add and subtract, get everything on left side. So the first one would become x minus square root of 3 is 0. Second one, we'll add square root of 3 and get x plus square root of 3 equals 0. And then we'll do that with the i's. So minus 5i, x minus 5i equals 0. And then the last one's negative, so I'm going to add 5i. X plus 5i equals 0. Yeah, I knew I didn't do enough foiling a while ago, I think. All right, so all 4 of these are set to 0. So now the product can be set equal to 0. All right, so since all these are conjugate pairs, I'm going to FOIL these two together and FOIL them two together at the same time and put each one of those in their own parentheses. So x times x is x squared. X times square root of 3 is a positive square root of 3 times x. Negative square root of 3 times x is a negative square root of 3 times x. And then square root of 3 times square root of 3, that's going to be a negative square root of 9. All right, second parentheses, we got an x times x is an x squared. X times 5i is a 5ix. Negative 5i times x is a negative 5ix. And then negative 5i times 5i is a negative 25i squared. So notice, first parentheses, square root of 3x is canceled. Second parentheses, 5ix is canceled. So here's another question. What can I replace I squared with? And y'all's calculator can answer that. Hit second decimal.
-1.
What was it?
-1.
-1. So that I squared has to be turned into a -1 so that that -1 is going to turn that negative 25 into a positive 25. All right, so the first parentheses, that's going to be x squared minus. So what's the square root of 9?
3.
And remember, we also said the other day that a radical times itself in the long run just gives you whatever number was under it, okay? All right, so now over here, you said this was x squared and then plus 25. So y'all remember this one rule. Anytime you FOIL conjugate pairs of radicals, they're going to end up subtraction. Anytime you FOIL conjugate pairs of imaginary, they're going to end up positive. Okay, every time. All right, now FOIL that and we will be done. So x squared times x squared is x to the 4th. X squared times 25 is a 25x squared. Negative 3 times x squared is a negative 3x squared. And then negative 3 times 25 is negative 75. And that one, we just got to write out what we're done. But we got one more step, I guess, right? Because x squared's an x squared. So bring down your x to the 4. 25 minus 3 leaves you 22x squared minus 75 equal to 0. Now remember, in MATLAB, they're going to give you the f of x. All you're putting in is your polynomial. So do not include the equal 0 part when you're putting them into your MATLAB, okay? Okay, so I think that was actually 20, right?
Yep.
Yes.
So you're going to have a little bit of knowing that end behavior chart for sure. A little bit of synthetic division and a little bit of this foiling. So I think this test not too bad. I usually get more decent grades on this one than I do my second one. So practice that, and then remember, try to get this test out of the way because we'll be finishing up 9, and then that'll give us a lot of time next week to do our reviews for that final and stuff, okay? So I think I'll stop our recording.